Myself Janil Popat. I welcome you all to understand soil consolidation. This is video part 2. In this video, we are going to learn Terzaghiy's one-dimensional consolidation theory as well as consolidation test setups and square root of time fitting method. Let us start. So, Terzaghiy's theory is among most popular theory for consolidation. Let us understand assumptions for Terzaghiy's one-dimensional consolidation theory. Soil must be homogeneous. Homogeneous means it is made up of same material. Every soil particle should be of same material. Soil should be fully saturated. It should be full of water. Voids should be filled with only water. No air should be there. Darcy's law should be valid. So we have understood Darcy's law in previous videos. So it should be valid. Compression and flow should be one-dimensional. Now, one-dimensional means if you are giving compression in only one direction, flow should be only in one direction. So it is confined from all sides and only one-dimensional flow and compression should be there. Soil particles and water should be incompressible. So soil as well as water are not compressible materials. Coefficient of permeability should be constant. So K, that should be constant. Soil is laterally confined. So from lateral directions, soil is confined. It is fixed from lateral dimensions. So consolidation in vertical direction only will take place. So let us move further. Relation between void ratio and effective stress should be constant. Let us move further to theory. Terzaghiy's theory of one-dimensional consolidation. We all know that the rate of settlement of soil and dissipation of excess pore water pressure is directly related. Now, to relate them and to predict time rate for consolidation, we need some concrete theory, and Terzaghiy's theory is amongst popular theory of them. Due to Terzaghiy's theory, we can find at any elapsed time, at any depth, we can find out consolidation and pore water pressure of the soil. Let us move further and understand Terzaghiy's theory. Here in this diagram, you can see that the clay layer is in between two sand layers. Clay layer is consolidating layer here. Now we have assumed some element of size dx by dz here. In other two diagrams, you can see intensities of time as well as degree of consolidation. Here Terzaghi has empirically derived the formula for del u by dt is equal to k 1 plus E0 upon AV into gamma w into del square u by del z square. Further, if we analyze it and we assume this section as CV, CV is defined as coefficient of consolidation, which is denoted by C and in suffix V, is equal to K into 1 plus E0 upon AV into gamma W. Here we know that AV upon 1 plus E0 is MV, so we can write MV there. Now if we want to find coefficient of permeability K, we can find out K is equal to CV into MV into gamma W, and hence we can write del u by dt is equal to CV into del square u by del z square. Furthermore, if we are talking about single drainage, there is a different case. If we are talking about double drainage, there is a different case. Let us understand single drainage and double drainage both. Now, if there is a only single layer of drainage provided either at top or either at bottom, there is a single drainage case. And if there is provided on both the sides as a drainage medium, like here we have taken, so it is a double drainage case. So small d is equal to h will be here. Now Small d is what? Small d is the length through which water has to go to reach the drainage medium. That is small d. If you are using double drainage soil, you have to take d is equal to h here as we have taken. And if you are having single drainage soil, you have to take d is equal to 2h, because the length will be greater in single drainage. In double drainage it will be shorter, so we have to take half the length. Let us move further. Furthermore, Terzaghi has given a non-dimensional factor, which is TV, that is called as time factor. He has related coefficient of consolidation with time factor like this: TV is equal to CV into T by D square. We understood D in just previous 1 minute. T, that is time period. For whatever time period you want to find time factor, that is T, and CV is coefficient of consolidation here. In addition to this, Taylor has given a relation between U and TV time factor. U is degree of consolidation here. Now, if degree of consolidation is less than 60%, then TV formula can be written as, empirical formula can be written as pi by 4 into U by 100 square. And if U is greater than 60%, we can write TV is equal to 1.7813 minus 0.933 log 10 base 100 minus U. So this is how we can find out degree of consolidation as well as time factor. Let us move further. Consolidation test. The consolidation test is conducted in a laboratory to study the compressibility of a soil. Now, consolidation test is done with consolidometer, or it is also called an odiometer. Now, consolidometer is made up of two things, that is loading frame and second is loading cell. The cell will keep the soil and loading frame will apply loading. For that, the soil specimen of size 60 mm dia and 20 mm thickness is taken. Then the loading is given in incremental manner. As we complete the loading cycle, in the last, load is not taken up to 0, but it will be reduced to 1/4 of the final load, and then it is kept for 24 hours to swell. After swelling and completion of that cycle, the soil will be taken out, and then some of the few things will be found out, like coefficient of permeability, coefficient of consolidation, coefficient of volume change, etc. Let us understand two types of cell today, which are as shown. Let us understand floating ring cell. Here, soil specimen is kept in this middle area. Item 1 is showing soil specimen. Then it is kept in between porous stones, as second is showing porous stones. And there are three types of rings kept: specimen ring, guide ring and outer ring. We can see rings here: specimen ring, guide ring which is guiding only, and fifth one is outer ring. Furthermore, water jackets are provided at item number 6. You can see that these are the walls, or we can say water jackets. They provide water. And 7, below that there is a base kept, as well as pressure pad is kept here. This is a pressure pad, and at item number 9 this is a pressure ball. Here there is a ball kept. From that ball the load is given so that the axial loading can be comprised of. Furthermore, rubber gaskets, bolts and drainage tubes are also provided in floating ring cells. But it is floating ring cell due to these rings are floating. Floatable rings are there. That is why it is floating ring cell. Let us move further and see the another type of cell, that is fixed ring cell. Here you can see the figure of fixed ring cell. Due to no floating arrangement, it is fixed ring cell. Here also the soil specimen is kept in between porous stones, and here specimen ring, guide rings are also provided, like here as I am showing this. Specimen ring and guide rings are provided. Furthermore, it is having water jackets and base as same of item number 5. Furthermore, pressure pad item 6 is showing, and item number 7 there is a pressure ball. Again, the ball will be providing axial loading to the soil specimen. Let us move further. The square root of time fitting method. The curve between dial gauge readings and time obtained from laboratory consolidation test, and the theoretical curve between U and TV. U as degree of consolidation and TV as time factor is almost similar in shape. To use this similarity and to find out coefficient of consolidation, we are using the square root of time fitting method. This method is given by Taylor. In this method, let us understand this theoretical curve first, and then we will go to laboratory curve. Here it is given the curve is between degree of compression U and under root TV. Here you can see the graph is staying linear up to 60%. After that, up to 90%, it is changing its shape. If I extend this linear graph up to here and give it a name A, the width A, and actual graph width as B, and compare them, so B by A is coming 1.15. In simple words, it means if the graph is not linear, it is 1.15 times than the linear value at 90%. We should also remember that we have studied in Tarzagi's theory that when U is lesser than 60%, TV will be pi by 4 into U by 100 square, and when it is U is greater than 60%, then TV will be 1.7813 minus 0.933 log 10 base 100 minus U. This is our old equations. Let us move further. Yes, this is practical laboratory test curve. Dial gauge reading versus square root of time under root T readings. Here R0 is corresponding to initial reading as well as up to RC. After giving some more pressure, the graph will happen like this. Now between R0 to RC, the line between R0 to RC or reading between R0 to RC is known as immediate settlement or initial consolidation. Now after that, from RC to line B is drawn. Now line B is 1.15 times line A. Now from graph, from that experiment, for particular experiment we can get this under root T90 value as 5.5 minutes up from point P, as the point P is showing 90% degree of consolidation as dial gauge reading as well as in terms of under root T. Now as having these values, we can calculate that under root T90 is 5.5 minutes, then T90 is equal to 30.1 minutes, as well as T90 can be called as 1806 seconds. From that we can remember that CV is equal to TV90 into D square by T90. This is again older formula from Tarzagi's theory. Let us move forward. We want other values in this formula. We have T90 only. Now we need D as well as TV. Now for TV90 as time factor, we have to use formula for greater than 90% of degree of consolidation, as U is greater than 60% as 90%. So here I am putting U value as 90 and I am getting the answer as TV of 0.848. So I got my TV, I got T90 I need D value. Now D is average drain path to reach the water. Now D is equal to H by 2, or we can say H initial plus H final by 2. Now H initial and H final from experimental value, we have to take HI as 16.20, HF as 15.10 mm. So initially the size of soil specimen was 16 mm and then it is reduced to 15.10 mm. Now putting these values in D, I am getting D answer as 0.783 centimeters. Now I have D value, T90 value and TV time factor 90 value. Now I can calculate CV from this equation. Putting all the values, I can get the answer as 2.88 into 10 raised to minus 4 centimeter square per second. So this way I can find out coefficient of consolidation of any laboratory experiment from similarity of theoretical curve as well as laboratory curve. I hope you are clear with this method. Let us move forward. Consolidation settlement. Now you guys have to remember these most important two settlement formulas. These are SC settlement, consolidation settlement is equal to MV into H into delta sigma dash. Now MV is coefficient of volume change, H is thickness and delta sigma dash, that is effective pressure difference. Again SC is equal to CC, that is compression index, into H by 1 plus E0 into log 10 base sigma 0 dash plus delta sigma dash upon sigma 0 dash. Now sigma 0 dash, that is initial effective pressure, and effective pressure difference, that is delta sigma dash. And H is thickness here and E0 is initial void ratio here. So I conclude my lecture here. Thank you.